We can accumulate here also. So lunch will be available here.
I have. Here. Can you plug this in? Maybe here or any point here? Yeah. No problem. I'm just making everything ready. Can I have one or two other colors like blue, green? I mean, not urgent, but and also I need a eraser. Eraser. Whiteboard.
Eraser?
Whiteboard eraser.
Yeah, okay, sir.
And maybe 2-3 other colors. Not urgent, but you can have it like tomorrow or.
On black?
Black and red I have.
Blue, I think there. No.
Blue, no blue.
I will get some blue. Blue is not here. I'll just get it.
Pointer no need.
एक दो फोटो ले लेना बीच में, आगे पिक्चर, हाँ बस आइए, आ जाइए, हाँ एक दो फोटो बस ले लीजिए, लाइव शो है उनका।
The mic is with me.
1 minute sir, then I'll
Yeah.
just to start it. Once again, good morning to all. We are resuming this session after inauguration. Today we have 3 lectures, 2 lectures of 1.5 hours, 1.5 hours each, are going to be delivered by foreign expert Process and Prem. Thereafter, they are pre-lunch. Post-lunch, we have very interesting lecture on very fundamentals of magnetism. There we will talk about very interesting thing, units, okay, units and very essentials in magnetism. That will be talked about Shruti Shukla. And after that, there will be a tutorial class that we will coordinate. So the very first lecture will be delivered by Process and Prem. Thereafter, another lecture by him only. So I request, I invite Process and Prem to start this GIN program with his very first lecture on physics of magnetism and related effects. Process Prem sir.
Okay, so good morning once again. So this morning when Professor Nimesh talked about the title, so he mentioned ABC will represent everything. Okay, so I want to say that A to Z, like Amazon, right? A to Z represents everything. ABC represents just the introduction. Okay, so I cannot teach all the aspects of magnetic recording. So ABC represents just an introduction to magnetic recording. So this title was coined by either Surbi or Professor Naresh, or together they come up with this title and they justify, because you are going to learn the basics of magnetic recording in this module. Okay. So this will set the tone of this particular course. Okay, so you might have thought that I am going to talk something very serious. So don't be very serious, just be relaxed. So I am going to talk about some advanced topic. It's not a simple topic. It's not an introductory topic. It's an advanced topic, but we will carry forward with in a light tone. Okay, so I will try to teach you in a very simple manner. So that's what you are going to expect in the next few days. So let me go back to, I don't know how the slide got changed. Okay, so this slide sets the tone of this particular course. So you would have known about Avatar movie, right? So 1, 2, 3 got released recently. So the first movie of Avatar got released in 2009. So at that point of time, it became the top grosser in Hollywood. So the director of Avatar movie, James Cameron. So he conceptualized the concept of the movie in 1996 or 97, and for about 10 years he didn't start shooting this movie. Okay, normally our directors, if they come up with some concept, they may make the movie within 2-3 years or maybe even 1 year they will finish, but this took almost 10 years to start the movie. Okay, so there is a reason that you will find at the end of this particular chapter. So the reason is not finding producers, that was not the issue, but some other reason. Okay, so I will tell you the reason towards the end of this particular part. So in this course you will find that there will be some introductory stuff which will cover 10% of this course. Then we will spend around 30% of our time on learning the fundamentals related to magnetism. Then we will learn about magnetic recording. Maybe this is around 20, this 50, somewhere there. It will fluctuate. Then towards the end, I will teach you some aspect of magnetic memory and emerging technologies. Okay, so we have a program. Maybe I won't go exactly according to this program. So, some of the day 5 content may be discussed today, because that forms the coherent flow, but this is a rough guide on what will be covered. Okay. Especially my part, I will go with certain flow, so that it is easy for you to follow. And this course will be interactive. So, I will ask questions, and I also expect you to ask questions. So, sometimes what happens when you teach a subject for a long time, you assume that the students know, but sometimes you may not know. So, if you do not understand, stop me, ask question, and I will also ask you question. Okay. So, the questions will be carried out through this app called OOCLAP. So, you can scan this QR code, take your mobiles, scan the QR code, and you should be able to join. If it asks for your name, you just type some name or your name, it does not matter. And you can also go to the browser, go to clap.com and enter Gyan day 1 as the code. Yes, so let us move on. So, first question is very simple. Right? So, if anyone hasn't still joined, you just scan this QR code and join. So, there will be various types of questions. So, some questions will be multiple choice like this. So, you choose one or the other options. Some questions you may have to type in your answers. Some questions, I mean, for this kind of question only one answer is right. For some question maybe 2-3 answers are right. So, you may have to choose maybe more than one answer. Okay, so, this question is basically checking who is that. This answer is definitely wrong. If you can see this question, then it should be yes, right? Okay, but this gives me also a feeling of how many of you are really into the lecture. So, if you are not paying attention, or if you do not get what I am teaching, then there will be many wrong answers. So, this way I can gauge how the course is going on. Okay. Okay, next question, you have to type your answer. So, why did you choose this course? Okay, so, there are many answers helpful in research, to some get some idea on spintronics. I want to boost my knowledge, all these things. Okay. So, I will have a look at your objectives later, but this is what I tried to give you in this course. So, in this course you won't learn much in terms of pure physics. Okay. So, I guarantee you that there may not be more than 10 equations in this course. Okay. So, all the discussion that I am going to have with you are mainly conceptual, no mathematics. Okay. So, there is nothing much pure physics, but when you go away from this course, you will have some knowledge of how the hard disk storage works, how the memory works, and you will have some ideas reinforcement of material science concept that you would have already learned, and you would learn how to apply material science for applications and how you can apply your physics to come up with technology and so on. Okay. So, this is what you will take away from this module. Okay. So, again we will go through some question. So, name the first ever information storage system that the human beings have ever used. So, those at the back, can you hear me? Okay. Okay, so there are various answers. So, when I show you a cloud like this, the one with the biggest fonts represent majority of the answers. Suppose more people answered hard disk, that will appear bigger, but the correct answer here is the human brain. Okay, our brain is the first information storage systems that the human beings ever used. So, it is not a physically built system, but it is not a system built by humans, but it is built by nature. So, this is what we used first. Then I will add on some more points to this question in a few minutes. Okay. So, people first used the brain, then they moved on to use stones, rocks, then the Chinese came up with the paper, then people started using palm leaf. Then when we got into technology, people started using this kind of punched papers, punched rolls, magnetic tapes, magnetic drums, hard disk drives, CD, DVD, floppy disk, and miniature hard disk drives and so on. So, this is how the technology or the information storage systems have evolved, and in this particular course you will be learning about magnetic recording, which is being used in the tapes, drums and so on. And if you look at the evolution, so for technology perspective, we moved away from punched paper to floppy disk, CD, DVDs, hard disk, and now the information is stored in the clouds, just like Professor Naresh told you this morning. Now, you may not, I do not know how many of you have seen a hard disk drive. How many have seen a hard disk drive? Okay, a few of you have seen a hard disk drive, but if you are not using a hard disk drive, but you are still using a hard disk drive, because the information that you upload into YouTube or Instagram, they are mostly stored in the hard disk drives, okay, in clouds. Okay, so this is how we store the information. Okay, so I told you that I am going to talk some more aspects related to the information storage systems. So before that, let me play this video. Okay. So you watch the video. Now you tell me what did you think while watching or after watching the video. You can type in your answers. Okay, so the information change as it passes from one person to the other, and it's not the same when it reaches the last person. Okay, this is what I wanted to bring. And another aspect is, I mean, not some people, all of us cannot remember everything. Okay, so we can only remember certain information, and we cannot remember all the information correctly. Okay, so these are some reasons why we need information storage systems. So we cannot remember everything, so we need to we need to take notes. So we take notes in paper or whatsoever. So that's one reason why we need storage systems. And also, if you want to pass information from one generation to another generation, for example, those days the kings have some remarks set in the stone. So when we read those stone imprints, then we know what happened during that kingdom, right? So those kind of information, I mean, that time stone was the information storage available. So people embed their status in, now we enter our status in Facebook or Instagram, but at that time they post their status in rocks, and that gets passed to the coming generation and so on. And most importantly, information changes as it goes from one person to another person. For example, you watch some video, some movie, you tell the story to your friend, you have some scene in your mind, but your friend who is receiving that story might visualize it differently. Okay, but on the other hand, if it is a video you send by WhatsApp, then both of you are watching the same content. Okay, so to reliably pass one information to other without changing the content, we need information storage. So all these are reasons why we need storage systems. I mean, in the past, now we have like so many things like artificial intelligence, banking, insurance. We also need to store data and so on. So many things happen digitally. So for all this, we need storage systems. Okay. So in the past, I used to show this trend of my emails that the data is growing, but now you know that we have so many applications like Facebook, YouTube, Instagram. So we upload reels, we upload videos in YouTube, Facebook. All these lead to a lot of content. Okay, so all these servers that store information in YouTube or Facebook, they get populated with the data every day. Okay, so this is something that I wrote in 2018. So at that time, about 10 power 21 bytes of hard disk drive space was shipped. Okay, roughly the hard disk drives shipped per person was 100 gigabyte. That is the kind of thing. But people also generate lots of data. So every year the data keeps growing, and we need something to store information. So if you look at YouTube, Facebook, I mean, these are very old data, but all these are generating lots of data, and they are stored in some servers. Okay, so you would have learned that now Google is coming to India, setting up data centers in Hyderabad or somewhere like that. So all these data centers are basically for storing information. So they may be used for artificial intelligence, or they may be used for serving the YouTube videos and so on. So in all the data centers, almost 80% of the storage is stored in hard disk drive. Okay, roughly 20% or less is stored in solid state drive. Solid state drive is a semiconductor technology, whereas the hard disk drive is a magnetic recording technology, as you will learn from this course. So to accommodate all the new data that is coming, we have to increase the capacity of the hard disk drives. Okay, so in hard disk drive you will have multiple disks in one box. Okay, one hard disk drive, there will be multiple disk. So you can probably increase the number of disks. Suppose you use 3 disks to store information, now you may increase to 5 or 10, but that is not very practical. Okay, so it requires more factories. Okay, so you might notice that the price of DRAM has increased compared to the past 2 years. Okay, usually semiconductor technology, as far as I know, the price always goes down, but in the last 2 years I see that the price of RAM has increased. So this is an unexpected trend. Okay, this is because there is a huge demand of memory for artificial intelligence. So that's why the price is going up, because the factories cannot supply the memory. Okay, there is a huge demand, but factories have a limitation to produce the memory. So in a similar sense, if you also increase the number of disks that you use per hard disk drive, it requires more factories to meet the demand and so on. So the ideal situation is like you have one disk. So within one disk, suppose you store 1 terabyte, you improve the technology so that next year you store 2 terabyte in the same disk. So that's what is preferred. So that's basically called as increasing the areal density. Areal density means the number of bits that you store in a given area. So you want to increase that. That's what is supposed to happen. So for that, the technology, the physics, material science, all aspects of a hard disk drive have to improve. Okay, so for example, this slide shows what happens as a function of time in video technology. So if suppose you bought a phone like 10 years ago, your phone would store videos in DVD format. Okay, that's called SD. Then a few years later, your phone would have been able to store information in full HD. That means 1080 in the vertical and 1980 in the horizontal, that kind of format. And now most phones have 4K UHD camera, and some phones also may have 8K UHD camera now. Okay, so what happens? You are increasing the resolution of the videos that you generate with your phone, and when you increase the resolution, the number of pixels get increased, and the number of the space you need to store these videos also will keep increasing. Okay, so if you look at a full HD video, uncompressed video, if you want to store 1 hour of full HD video will require 0.179 terabyte. But if you want to store uncompressed 4K UHD video, you need 7 terabyte for 1 hour of video. Okay, 8K UHD, you need 86 terabyte per hour of uncompressed video. Okay, so as we move towards better technologies, again we need more space. It's not that more people are coming and generating data, and we are generating data at very high capacities. So all these are reasons why the hard disk drive is an important technology and why we need to improve that technology. Okay. So how many of you know the difference between memory and storage? What is memory? What is storage? Okay, so quite often people get confused what is memory, what is storage. Okay, So, I always like to give some analogy. So, you can think of the memory like your table. Okay. Suppose you have an exam tomorrow on quantum mechanics. So, most likely the things that you will find on your table is all related to quantum mechanics. So, you want to study for tomorrow's examination. So, all the quantum mechanics notes are on your table, then you read about them, then go for the exam, right. All the other books like say maybe classical mechanics or something else, they are all in the shelves. Okay. So, memory is like your desk where you keep the information that is immediately relevant, and the storage is like your shelf or cabinet. You do not need this information now, but you want to store a lot of that information somewhere, so that when you need you can take from there. Okay. So, storage is something like that. So, you do not need that information immediately, but you want to store them somewhere. So, the concepts that you would have come across like DRAM, SRAM, cache, all these are memory concepts, whereas the SSD, hard disk, these are storage concepts. So, in hard disk or tape, in SSDs, you are basically storing information that you may need sometime, but you do not need all the time. Okay. So, that is the difference between memory and storage. So, hard disk is a storage device, MRAM, DRAM, those are all memory devices, hard disk is a storage device. Then in the computers, we also have a hierarchy. Okay. You have a CPU, the CPU does the computing. So, the computing, it needs some information, right, it cannot do something on its own, it needs something. So, the information it needs immediately are stored in the cache, and if it's need slightly on a lesser time scale, you store them in random access memory and so on. So, what is currently being computed is mainly in the RAM, cache and so on, and if it needs further information, it will get from the hard disk drive and so on. So, if you go down, so CPU, closer to CPU is cache, then the next level is RAM, then hard disk drive, and if you go further it may be cloud or somewhere. Okay. So, cloud is far away from the CPU. Okay. So, this is how the information is stored. So, this all are arranged based on two things, one is the cost, speed and also size. Okay. So, if you make very fast cache memory, that is very expensive. So, that is why cache memory usually store very small information, then random access memory can store even more information. So, if you look at this speed, right, you can see that cache is like 1 nanosecond kind of time scale. So, information can go from cache to CPU in 1 nanosecond kind of time scale, information can go from RAM to the CPU in 100 nanosecond time scale and so on. And if you want to access information from hard disk, at first you need a 10 millisecond kind of time scale to find out the location, but once you read the first information, all the other data can go at very high speed. Okay, so that is one thing. Secondly, also the cost. So, if you look at the cache memory, it is like $150 per megabyte, and RAM is like 0.58 per megabyte. This is very old data, but this gives you some kind of picture which is more expensive and so on. So, if you find out, if you look at the hard disk drive, it is very inexpensive. So, just like Professor Naresh told you, the cost that we pay for every bit is very less. Okay. So, hard disk offers you large amount of data to be stored at a cheap price. So, this is the main advantage of the hard disk drives. Okay, so, this hierarchy is not only in the hard disk drive, this is also available in mobile and so on. So, if you take mobile, I mean some laptops and so on, there again you have many kind of drives. Now, hard disk drive is taken away by solid state drives. So, in my laptop also does not have hard disk drive. For a long time I was patriotic, I always buy laptops with a hard disk drive, but now my university doesn't give me laptop with a hard disk drive. So, so my laptop also has only solid. Pardon?
Any reason why
One thing is like solid state drives are like lighter. So hard disk drive has maybe, let's say that's 50 gram, this may be like 20 gram lighter. That's one thing. Power consumption. So hard disk drives have motor. So motor requires more power. So power consumption is larger. Solid state drives don't consume that much power. So all this makes the laptops to be lighter, portable, and battery will be lasting longer. So these are the main advantage. Otherwise, in terms of reliability, there is no big difference between SSD or hard disk drives. Okay, so that's called a data hierarchy. Okay, so let's do some questions to reinforce these concepts. Okay, again go back to UCLAB. So these UCLAB's questions will come throughout the lecture. So don't close your browser. Just keep your browser on.
Can you please share that scan?
Okay. Can you scan? Okay. So keep this tab on all the time. Okay, so in this question, you are doing something, some simulation or whatsoever. The data handle is not much, so only you need a lot of computing power. So in this case, since the data is not handled much, so you don't need the best hard disk drive. You need, I mean, the concept here is that you need a good CPU. Okay. Okay, let's go to the next question. Now, your supervisor asks you to do a job that handles and generates lots of data which need to be stored for several years of occasional use. Then what will you choose to use? Okay, so this is one question where you can click multiple options. Okay, not all questions have only one option. So there are some questions with many. You can choose many options. Okay, so in this case, you are doing some computation. It generates lots of data. So you need the best CPU because you are doing lots of computation, and you need lots of data. So you need a best memory also, and you need a hard disk drive because you are storing data for a longer time for occasional use. So all the 3 or 4 answers are correct. Okay. So basically, how we choose memory or processor depends on our use. Okay. For example, I don't do any gaming, so my laptop doesn't have any GPU. But if you are gaming, then your laptop will have a GPU, and you don't mind heavy laptops because you are all young, and I choose light laptops because I don't want to carry heavy loads. So people always choose the CPU, memory, hard disk drive or whatsoever based on their requirement. That is the concept. Okay, so now we slowly move on to learning about hard disk drives. So hard disk drives were applied in computers and servers since mid 1950s. So today, this morning, Professor Naresh told you that IBM introduced the RAMAC, random access method of accounting something. So RAMAC is the first ever hard disk drive introduced by IBM in 1956. So actually, this year we are celebrating 70 years anniversary of the hard disk drive. So at that point of time, it was mainly used in the computers. Computers were not accessible to common people in 1950s. Only some organizations like banks used to use computers at that point of time. Then in 1980s and later, computers became commonly available to people. So we had personal computers, then later laptops came and so on. And in 2000s, hard disk drives also got into consumer electronics. Okay, so even now, if you look at Xbox has a hard disk drive to store your programs and so on. And in 2000, we had video recorders, and there was a product called iPod. So iPod is the predecessor to the Apple iPhone that you use now. Okay, iPod you cannot make phone call, but iPod used to look like iPhone, and you can play lots of songs. Okay, so before iPod came, the players usually have like a few 1 or 2 gigabytes of storage, and we could store like hundreds of songs. But when iPod came, 30 gigabyte, you could store thousands or more songs. Okay, so this was a very revolutionary product. Okay, so Apple became very successful after they introduced iPod. Then later, I mean, it was successful for some time. Then Steve Jobs left. Then Steve Jobs came. Then Apple introduced some desktop model, but only after the iPod, iPhone, and things like that, Apple became very popular. Okay, so initial iPods use a hard disk drive. So they were like mini hard disk drives. So roughly this size. Okay, very small. So within this small hard disk drive, you can store 30 gigabyte of information, which means you need like 5 megabyte of storage for one song. So 1 gigabyte will be how much? So 5 megabyte times 200 will be 200 songs per gigabyte, right? So 200 multiplied by 30 is like 6,000 songs you can store in 30 gigabyte. So this was a revolution at that point of time. So this is how the hard disk drives technology grew. Okay, now we slowly move into how hard disk drive is going to work. So I am just going to give some introduction now. We will discuss the details of physics and material science later part. So if you open a hard disk drive, it will look something like this. To be precise, open hard disk drive will look something like this. So you see a disk, right? So this disk is rigid. That's why the name hard disk drive. Okay, so before this, people used to floppy disk. Floppy disk is like a foil kind of thing. So is floppy. Like it's not rigid. It can fluctuate. So floppy disk is not rigid, but this hard disk drive is a rigid. That's the name, hard disk drive. It doesn't bend or so on. So we have a rigid disk. On this disk we store information. Okay, so the information is stored in concentric circles. So how many of you have used a CD or DVD? Okay, so do you know how the information is arranged in CD or DVD? Is it concentric circles or any other? No. Okay. So in CD or the old record players, the vinyl, the information is not stored in concentric circle, they are spiral. Okay. So, the information goes from outer region to the inner one through a spiral track. Okay. So, the head you place in a vinyl record, or the head that reads the information in a CD or DVD, they go in spiral track, whereas in hard disk drive we have concentric circles. So, we do not have spirals, we have concentric circles. So, this is what we call tracks. So, the bits are stored in tracks. So, like in a stadium you have like track 1, track 2, track 3 and so on, many tracks, right. So, in a similar sense, in hard disk drive there are many tracks, and these tracks are so advanced now. So, if you look at current product, maybe this track is 50 nanometer or maybe even smaller. I am not very updated with this technology now, exact number I do not know, but it is somewhere there. Okay. So, we have the space between the center of this track to the next track is only 50 nanometer. So, you all know that 1 nanometer is 1 billionth of a meter, right. So, you can imagine 50 nanometer is how small. The hair, for example, hair is 100 micrometer diameter, right. So, this is like almost 2000 times smaller than the hair. Okay. So, that is the kind of track we are talking about in hard disk drive. And if you count the number of tracks between the inner diameter to the outer diameter, so there are around 700,000 tracks. So, 7 lakhs tracks are there between the inner diameter to the outer diameter. So, these days we are storing information in two types of hard disk drive. One is like 97 millimeter. So, in the 97 millimeter hard disk drive, so this will be, let us say this is the center, let us say the radius starts at 25 millimeter, then you go all the way to the outer diameter, which will be like 46 millimeter or so. So, from 25 millimeter to 46 millimeter, there are around 700,000 tracks. So, that is how dense these tracks are placed. Okay, so, inside each track we have the data. So, if I zoom in and look at a particular track, so this is one track and this is another track. Okay. So, I can do some, I mean in this case I am using very old technology. So, I can use the magnetic force microscopy to look at how the bits are stored. Okay. So, magnetic force microscopy will give you like the contrast. So, yellow or brown color to represent bit 1 or 0, for example. So, here let us say we store 1 0 1 0 1 0 something like this. So, these are all bits. Okay. So, within one track you will have lots of bits. Okay. So, you go from here, count 1 bit 1 2 3 and so on. So, there will be like again billions of bits. Okay. Within one track there will be billions of bits, and so we have lots of tracks. So, in each track we will store several bits. Okay. So, we have some number to quantify a hard disk technology. So, when you go to say some electronic shop and you want to buy RAM, DRAM for your computer, right, then what number do you use? When you buy a DRAM, what number do you use? So, there is some number, there is some unit, gigabyte, right. So, you go to the shop and ask, maybe I need a 12 gigabyte DRAM, right. So, which is superior, 8 gigabyte or 12 gigabyte? 12 is better, right. So, you have some number and unit to tell how superior is certain technology. So, if you have 4 gigabyte RAM, that is not as good as say 12 gigabyte or 24 gigabyte RAM, right. So, we need some numbers to say which technology is superior. So, again for example, again RAM also, let us say one is operating at 133 megahertz, another one is operating at 266 megahertz. So, that talks about the speed of the RAM, right. So, you want the highest speed, highest capacity RAM. So, in a similar sense, We also use some numbers to express the superiority of a particular technology. So, you assess whether the technology is progressing by looking at some numbers. Okay. So, if you, when you were a child, probably the memory used to be like 1 gigabyte or 2 gigabyte, but nowadays the DRAM or like 12 gigabyte, 24 gigabyte and so on. Okay. So, the technology has grown and you monitor by looking at that number. Okay. So, similarly we have some numbers to quantify how the hard disk technology progresses. So, in this slide I will be talking about 2-3 numbers, exactly 4 numbers, okay, to describe the how the hard disk technology has been growing. Okay. So, out of the 4 numbers that I am going to talk about, only one of the number is used by common people. Okay. So, if you go and buy a hard disk drive, you will use one number, but those who do research in hard disk drive, they use 3 other numbers. Okay. So, the final number that you all see depends on these 3 numbers. Okay. So, the first number that the researchers use to track the progress of the hard disk drive is called track density. Okay. You know that IBM is in America. So, the hard disk drive technology came from America, and Americans are crazy about using units, right. They do not use SI unit, they use inch, miles and so on. So, hard disk drive we always use something with inch. So, we do not say number of tracks per meter, but we say number of tracks per inch. So, if you go from the inner diameter of the hard disk drive, outer diameter. So, from inner diameter you go towards outer diameter and count the number of tracks. For example, if the distance between this and this is 1 inch, okay, then 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 9 tracks per inch, something like that. Okay. So, you go from the inner diameter and to the outer diameter, you count the number of tracks per inch. So, that is one number that we use to quantify. So, in the current technology, this number is about 500,000 tracks per inch. So, we use TPI. TPI stands for tracks per inch. As a commoner, when you buy hard disk drive, you do not care about the TPI. You do not know what is the TPI in a particular hard disk drive, but this is some number the people who do research on hard disk drive will look at. Okay. So, basically we are counting the number of tracks per inch when we go from one diameter to the outer diameter. Okay. That is one number. Second number is the linear density. Linear density means for example, you go along the track. Okay. From here I start counting the number of bits, I travel 1 inch, then find out how many bits I store. Okay. So, it is the number of bits along a track. So, that is called linear density. So, for this one people use the word bits per inch. So, I travel 1 inch along this, let us say this is a track, right, and let us say this is 1 inch. So, here I count 1, 2, 3, 4, 5, let us say there are 25, then I say 25 bits per inch. Okay. In current technology, this is yeah, somewhere here. Okay. We are in 2 million bits per inch or 20 lakhs bits per inch. Okay. Outside India, we do not use lakhs or crores. So, we use millions, billions. Okay. So, roughly 2 billion bits per inch. So, that is the kind of density. So, within 1 inch, you know, 1 inch is roughly this length, right. So, within this length there are 2 billion bits, sorry 2 million bits. Okay. Can you imagine? So, within this small area there are 2 million bits stored in a hard disk drive. So, that is how densely we store information. Then the third number that we all use, I mean the researchers use to define how advanced is the hard disk drive technology is by coming up with a term called areal density. So, by the name you should know that it is the number of bits in a given area. So, this is again American technology. So, we use a square inch to represent the area. So, within 1 square inch how many bits we store. So, currently this is roughly 1500 gigabits per inch, square inch. So, this is the kind of density that we are talking about. Okay, so 1 square inch is like this area, okay, this area of my fingers. So, within this area we are storing 1.5 trillion bits. Okay, so that is a kind of dense packing of data that we have in hard disk drive. Okay, so this is also another number that you won't see, but the researchers will use these 3 numbers to track the progress of hard disk drive. Material we'll discuss later. We'll slowly go into that. Okay, the most common number that you will always come across is a capacity. So, when you go buy a hard disk drive, probably you are going to buy say 5 terabyte, 12 terabyte, something like this. Okay, so this is called capacity. So, I told you RAM, right? RAM you have 12 gigabyte, 24 gigabyte. So, that is the only number we know as a common consumer. We only know about the 12 gigabyte, 24 gigabyte of RAM. So, in a similar sense, when you buy a hard disk drive, this is the number that you all use to track, but behind this number there are a few other numbers like track density, linear density, areal density. These are what the researchers track. Okay. So, the eventual capacity, for example, if you make a 5 terabyte or 12 terabyte hard disk drive, so this capacity is a function of the areal density, the size of the disk, I mean the diameter of the disk, and the number of disk that you pack in a hard disk drive. Okay. For example, if you have this one, okay, how many of you know the difference between this and this? Yes, bits and bytes. Okay. So, quite often when we talk about the areal density, we talk about bits. Okay. So, we do not even write capital. So, we write bits per square inch, but when you buy hard disk drive, we are buying in bytes. Okay.
How closely these disks are packed?
It's about 5 millimeter, 4 to 5 millimeter kind of spacing. Okay, so since this question is asked, I will spend some more time to explain this slide. Firstly, the areal density determines the capacity. Let us say you have current technology is say 1000 gigabits per square inch. So, henceforth I will use gigabit to represent 10 power 9 bits. Okay, so giga is 10 power 9, tera is 10 power 12, and we are not talking about mega these days. So, we are in terabit, pico kind of things now. Okay, so let us say you have 1000 gigabits per square inch, then your disk has a diameter of 95 millimeter diameter, and let us say you use 2 platters. Okay. Let us say I do not remember the exact number, let us say this gives rise to 2 terabits per platter, or terabyte per platter, and if you have 2 platters, so your hard disk drive will have 4 terabyte. Okay. And let us say you advance the technology from 1000 to 1500, then for the same thing you will have like 6 terabyte, right. So, what is more important is improving this. So, if you keep improving the areal density, then you can achieve high capacity without increasing the volume or the power consumed by a hard disk drive. So, always the researchers focus on increasing the areal density. So, when people do research on hard disk drive, they want to focus on how many data you can pack in a given inch. So, if it is 1 terabit now, you want to do 1.2 terabit next year and so on. So, you want to keep increasing the areal density, so that you can achieve higher and higher capacity. Okay. Yes. Platter is a disk. Okay. 2 disks. So, when we say platter, is basically it refers to the disk. Yes. Yeah. So, as I told you, right, as a teacher who is teaching for many years, I might not know that you don't know the word platter. So, please ask question. Okay. So, sometimes I might take it for granted that you might know. Okay. So, if you don't know, please ask, interrupt, no problem. So, here, yeah, I have used a different word, but it means the same thing. Disk and platter are the same. Okay. This is a term used by Americans, so we all get to use this. So, final capacity depends on areal density, the size. Okay. So, our focus is always this. Suppose you have like 1 gigabit per square inch, now you want to make it 2 gigabit per square inch next year, 4 gigabit per square inch another year, and so on. Okay. So, this is what we want. Okay. But it cannot happen all the time, right. So, during some period of time this was possible. Okay. In early 2000s, people used to see double growth every year. Okay, 100% growth every year, but these days the growth is reduced because we are almost near the saturation. So, we cannot increase the areal density all the time. Okay. So, in that case, if you want to increase capacity, what you can do, you can make the size of the disk bigger. So, in the past, the hard disk drives had 2 sizes. One is a 65 millimeter diameter, another one is a 95 millimeter diameter. They always stick to these 2 formats, but in the recent years, people have moved from 95 millimeter to 97 millimeter diameter. Okay. Extra storage space. Okay. So, the size of the disk plays a role, areal density plays a role in the final capacity. Then the next thing is the number of disks you use. Suppose you use 2 disks, 4 disks, so you can double the capacity, right. So, you can play with the number of disks to the final capacity. Okay. Another point I want to say is that in hard disk drives, we store information on both surfaces. Okay. So, let us say this is a disk side view. Okay. I am looking at the disk from the side. So, it is like this, right. So, you have a top surface and you have a bottom surface. So, in both surface we store information. So, we have a head that goes on to write and read information at the top surface, and we also have a a head at the bottom surface. So we use both surfaces of the hard disk drive to store information. So when I say one platter or one disk, so within one disk you have two surfaces, both store information. Okay, so because you have two heads, one at the top and one at the bottom, you cannot bring them too close. So that's why we have like a 4 millimeter kind of space. Okay, any questions here? Is it all clear? Okay, then let's do some questions.
We will take 1 minute break.
Okay, 1 minute break for me.
For everyone?
Okay, okay.
We'll take some.
Yeah,
already
yeah.
One lecture is almost over.
Oh, you mean one break you want to have?
Yeah. Can we have?
Oh, let's finish the question then.
Okay.
After the question we can. What time did we start?
10:15 we started.
10:15. Okay.
Am I right? We started.
You all have paper and pen?
Yes.
Right? Okay. So you need to do some calculation. I said no equation, but I didn't say no calculation.
They may ask ChatGPT also these days.
Okay, I am giving more time. Okay, so when I see 15 in very big font, which means most of you have answered 15, and I don't remember, but I guess this is the correct answer. Okay, so let's move on to the next question. I think there are 1 or 2 slides. I'll finish.
No, it's okay, it's okay.
Okay, most of you are right. Let's say we have a disk. So within this there are many tracks. Okay, so if I want to calculate the track density, I go from inner diameter to the outer diameter, travel 1 inch, then count how many tracks I have. So the correct answer is we have to go from the either outer diameter to inner diameter or inner diameter to outer diameter. So this is the path we need to travel. Okay, next question. Okay, so it's 2 million bits per square bits per inch. Okay, so roughly this number. So I told you the current technology has 2 million bits per inch. So in current technology, the bit length is like 12.7 nanometer. So you can imagine how small it is, right?
That is in longitudinal.
Conventional recording. No, perpendicular recording. Longitudinal doesn't exist anymore. Yeah, all perpendicular. Yes. Okay, I'm giving you some more time. Okay, so it's 500,000 tracks per inch. I told you the current technology is around this range, 500 tracks per inch, which means the center to center distance between two tracks is only 50 nanometer. So you can compare this with the size of human hair. Human hair is 100 micrometer. So this is like 2000 times smaller than the diameter of a hair. Okay, so that is the kind of technology we are in. So in this course, you will learn the fundamentals of magnetic recording, then the current recording technology, which is perpendicular recording media technology, and I will also touch on some future magnetic recording technologies. Okay, so now this is the right point for the break. Yeah, thank you. So we'll see after break. Yeah, okay.